This is test number 4 from the series 2. These tests is mainly based on waves and oscillations. Okay, the first question. Energy of sound, intensity of sound and intensity level of sound have the units in order. Okay, the energy of sound, so it is just energy. Energy is measured in joules. So you have to choose any of the option which has joules. According to that, first one, fourth one and fifth answers can be eliminated. The answer should be either second or third one. Because second one is obviously in joules. If you think about a third one, it is watt seconds. Watt means power. Watt second means joules per second times seconds. So the units watt second means just joules. So it also has the units of energy. The next one is intensity. Intensity means power divided by area. Power divided by area. So the power is you have to consider amount of power going through a cross section, a normal cross section. Power means the units of power is joules per second, and the area is meter squared. So the units here should be joules per second per meter squared. So in the third option, we have joules per second and per meter squared. Then we need, so this is intensity of sound. Then we need the units of intensity level. I'll just recall you the equation. Now this is the equation to find the intensity level. I divided by threshold intensity, that is I naught. So you should know the units of, this is the intensity level, beta. Units of beta is decibel. You have to know that. Or decibel, it could be bell as well. So here the option is decibels. So the answer for that should be the third one for the first question. Okay, the second question. Fundamental of a taut string is given by F equals 2L T of M root. The quantities in a graph which gives a linear graph are. So here the equation is F equals 1 over 2L T over M root. So here we need to choose two quantities in this equation, so we will have a linear graph. So according to this equation, we can gain these proportionalities: F1 over L, F proportional to root T. Okay. So in these answers, we don't have, we can see that we don't have this combination. F is proportional to 1 over L. So I'll move on to this proportionality. If you consider this one, you just have to square both sides. So you get F squared proportional to T. F squared proportional to T. So meaning of this is between F squared and T, T means the tension, we have a linear combination. But between F and T without root, we don't have a proportionality like this. We don't have a linear proportionality like this. But if you like square both sides, you have to square both sides. We can have a linear combination between F squared and T. So this is like Y, this is like X. So we can write, if Y is F squared, and x is t, we will have a graph like this. Here we need to make sure that y-axis is f squared, not simple f. Between simple F and capital T, we don't have a linear combination. But between f squared and t, we have a linear combination. So if you are going to draw a graph, first you have to square both sides of this equation in order to get a linear combination. So the experiment would be easier that way. So the answer for that should be the fourth one for the second one. Third one, in a taut wire, a series of harmonic frequencies can be. Okay, I'll just explain this a little bit more. You should remember that in a taut wire means a wire like this attached to two rigid ends. So this is taut. So we can have these patterns in that wire. So this is the fundamental. Then we can have first overtone, then the third overtone. If we keep increasing the frequency that we vibrate this wire, we can have these fundamental, first overtone, second overtone, third overtone, like that. So you have to remember this, like this is the f naught. This has a if this has a frequency f naught, fundamental frequency, this has 2f naught and this has 3f naught. So this is first, second and third harmonics. Harmonic means the multiples, full integer multiples of the fundamental. Those are the, so we can keep going like that. So the frequency pattern, frequency order should be like f naught, 2f naught, 3f naught, 4f naught, likewise n plus n, 1f naught. So we can have this. So you have to choose the pattern which relates to this one, f naught, 2f naught, 3f naught. So if you think about two consecutive harmonics or overtones, you can see the difference is always f naught. This minus this f naught, this minus this f naught, 4f minus 3f, also f naught. So always in a taut wire, for the overtones or the harmonics, the difference between two consecutive harmonics should be f naught. F naught means the fundamental frequency. So the only if you check that, if you think about first one, it doesn't have a constant difference between consecutive overtones, so we can remove that. If you think about second one, it has frequency difference of consecutive frequencies is 200, but the problem is those harmonics, those frequencies are not integer of, I mean multiple of integer of the fundamental. Third one also similar, it has constant differences between consecutive harmonics, but yeah, the third one is correct. It has constant differences, and it also follows f naught, 2f naught. So if you think about 50, 2 times 50, that is 100, 3 times 50, that is 150, likewise. Then we have 4 times 50, another one. So that matched with this order. None of the other match with that. So the answer should be third one for the third question. Okay, Fourth one, a musical fork makes beats 4 Hz with a string when its length is 49 centimeter and 50 centimeter. Frequency of the musical fork is, okay. So whenever they ask a question like that, it is better to draw frequency levels in ascending order like this. Let's say this is the fork, frequency of the fork. This level is frequency of the fork. Then you have a string whose length is 49 at one time and 50 at another time. Okay. If you remember this combination, f is inversely proportional to the length. So if the length is higher, frequency is lower. If the length is lower, frequency is higher. So we have a string with 49 centimeter length, which should have a higher frequency because its length is less, and the frequency difference should be 4 Hz. Then if you have a 50 centimeter length string, it also has 4 Hz. It also creates beats with 4 Hz with this fork. This is the fork. These two cases are the different lengths for the string. So in each case it makes 4 beats. Right. So let's say frequency of the fork is simple f. So the frequency of 49 length should be f plus 4. Frequency for the 50 centimeter should be f minus 4. Right. I'm going to get these two cases. We need to find simple f, which is the frequency of the fork. So I can write these proportionalities. F plus 4, this frequency is inversely proportional to the length. So that is 1/49. This frequency f minus 4 is inversely proportional to 50. Then now I have two proportionalities. I'm going to divide those in order to find simple f. So f plus 4 divided by f minus 4 equal to 50/49. If you divide these two, it becomes 50/49. Then you have to simplify this. 49 times f plus 4 times 49 equals 50 times f minus 50 times 4. 49f, 50f. So if you subtract that, this becomes simple f. Get this to this side. So 50 times 4 plus 49 times 4. I'll take 4 out. So this becomes 50 plus 49, which is 99. 99 times 4. 99 times 4 means 36, 39. So this is the frequency of the fork. 396 Hz for the frequency of the fork. So this is the only way. Once you get used to this is not a complicated question. You have to get used to these questions. The thing is, you have to draw this diagram clearly. Then you can clearly see the frequencies and frequency levels in each case, so you can figure out the equations easily. Okay, the answer should be the third one for the fourth question. Fifth question. Sound velocity in hydrogen gas at 0 centigrade is 1.28 kilometers per second. Sound velocity in a mixture of gases, hydrogen and oxygen, at the same temperature is, right? So here we have two cases. Sound velocity in hydrogen gas. So this is pure hydrogen. They say that is 1.28 kilometers per second. So that is hydrogen at 0 centigrade. Then we have a mixture of hydrogen and oxygen. So this is the first case. For the second case, we have a mixture of hydrogen and oxygen. Hydrogen means 2, oxygen means 32. These are the molecular masses. Okay, so the equation for the sound velocity is V equals gamma RT divided by capital M. So if we compare these two cases, pure hydrogen and mixture of hydrogen and oxygen, the variable should be only capital M, molecular mass. Temperature also is same for both cases. So we can neglect these. The variable, the proportionality we can choose is 1 over m root. 1 over m root. So we can only use this proportionality. Just forget about other, those are constants. Right. Here we know the molecular mass. For the first case, molecular mass is just 2. That is just hydrogen. Here we need to find the molecular mass for the mixture. They say volume ratio between hydrogen and oxygen is 4:2, 4:1. So you should also know that if the temperature is constant, for example, the volume is proportional to number of moles. Number of moles. So that volume ratio is given as 4:1. So hydrogen is 4, oxygen is 1. So this is the ratio. If it is a volume ratio, we can also say the number of moles ratio also is the same because those are proportional. Okay. Then I'll find molecular mass. Molecular mass is total mass of the mixture divided by total number of moles. Total mass is, for the hydrogen, molecular mass times number of moles. I can say that is 4 plus 4 moles plus, for the oxygen, 32 times 1 divided by, so the number of moles is 4 plus 1. Here we have 8, 32, 40. 40 divided by 5, that is 8 grams per mole. So 8 grams per mole is the molecular mass of the mixture. So you should know how to find molecular mass of a mixture. You just have to, so this is the total mass of the mixture at the numerator. This is total number of moles, that is at the denominator. So we got 8. Right. For the first proportionality, I'll say so this is 1280 is proportional to 1 over, it is just hydrogen for the first case. This is the first proportionality. Then other proportionality, you need to find that, that is V, that is proportional to 1 over 8 root 8. Second one. Then I'll divide second one by first one. V divided by 1280 equals root 8. Root 2 goes to the denominator. Root 2 goes to the denominator. Right. 2 over 8, that is 1 over 4 root. 1 over 4 root means 1 over 2. So this is 1 over 1280. V is 1280 divided by 2. So this is 640 meters per second. So this is the sound velocity in the mixture which contains hydrogen and oxygen. That is 640 meters per second. So the answer should be Second one for the fifth question. Okay, sixth question. At 324 Kelvin, sound speed in air is 360 meters per second. If its pressure is halved and temperature is increased to 400 kelvins, sound velocity in air is, right? So here you need to know the variation of sound velocity with temperature, pressure, like those stuff, right? If you know that sound velocity does not change with pressure, so this is the equation: gamma RT divided by capital M root. So in this equation we don't have a term for pressure, meaning sound velocity cannot change with pressure. Then you would remember this equation as well for sound velocity: gamma P divided by rho. This equation, gamma P, pressure divided by density. But this equation has a pressure term there. But then you can say this sound velocity depends on pressure as well. But the problem is, whenever the pressure changes, let's say the pressure doubles. If the pressure is doubles in a sample of gas, density of that gas also doubles by the same factor. So if this gets doubles, this also gets doubled, then the factor cancels off. So whenever the pressure changes, density changes by the same factor. So the pressure, by changing pressure, we cannot change velocity of sound. Right. So we can say this velocity is independent of pressure. Velocity of sound is independent of pressure. Then we can say this proportionally. These are obviously constants. We can say velocity of sound is proportional to root T, temperature. Okay, then we have to use this one. They have given at 324, speed is 360. 324. Then what they ask is sound velocity at 400 Kelvin. 400 Kelvin. What they ask is this V. So these are the two proportionalities. So V divided by 360 equals 400 divided by 324 root. Okay. So I'll just divide by 4. This is 100. 81. 100 root means 10. 81 root means 9. 360. V is 360 times 10 divided by 9. 140. So velocity is 400 meters per second. So this is the velocity of sound at 400 Kelvin. Remember, we didn't get a quantity for pressure. We neglected the pressure because we know that by changing the pressure of a gas sample, we cannot change the velocity of sound. Right. So the answer for that should be fourth one for the sixth question. Right. Seventh question. Sound velocity in air is 330 meters per second. Frequency of first overtone of an open pipe with length 60 centimeters is, right. So we have an open pipe, not a closed pipe. Open pipe means both ends are open. Closed pipe means one end is closed. Right. Then they ask frequency of first overtone. Okay. For the fundamental for open pipe, this is the fundamental. for an open pipe. First overtone, for that we need to go for another loop. We have to add another loop. So the only way we can add a loop is like this. So this is the first overtone. Length of the pipe is given as 60 centimeters. So if you think about lambda over 4, so this one part is a lambda over 4, lambda over 4, lambda over 4, lambda over 4. So we have 4 lambda over 4s. So this is just lambda. So lambda over 4 times 4 is actually the length of the pipe, 60 centimeters. So we can say lambda is equal to 60 centimeters. Then just apply this equation, V equals F lambda. V is 330 meters per second. Frequency means this is the first overtone, frequency of the first overtone, times lambda. We found lambda as 60 centimeters. 60 centimeters means 0.6 meters. So F1 is 330 divided by 0.6 divided by 6, both numerator and denominator. 6 means 5, 35. So this is 550 hertz. So this is the first frequency of the first overtone is 550 hertz. The answer should be the fourth one for the 7th question. Right, 8th question. Intensity of a sound wave with amplitude 0.1 millimeter is 3 watts per square meters. Intensity of a sound wave with the same frequency and amplitude 0.2 millimeters is. Okay, so here we need to have a combination between amplitude of a wave and the intensity of that wave, sound wave. So the intensity, you should know this, you should remember this. Intensity of a wave is proportional to amplitude squares. Intensity means the kind of like the energy of the wave. It is proportional to amplitude squared. Right. For the first case, intensity is 3 watts per square meter. Amplitude is 0.1 millimeters squared. So this is the first proportionality. Then what they ask is intensity of the second wave. Let's say that is capital I. Amplitude is 0.2 squared. Then 2 divided by 1. I divided by 3 equals 0.2 squared divided by 0.1 squared. 2 divided by 1. So 2 divided by 1, it is 2. 2 squared means 4. So I is equal to 3 times 4. That is 12. 12 watts per square meters. So here the amplitude has doubled. So the intensity should be quadrupled because it is squared. I is proportional to A squared. If A is doubled, intensity should be quadrupled, right? It should be increased by 4 times because it is squared. Okay, so the answer should be 12 watts per square meter. So the answer is 5th one for the 8th question. Okay, the 9th question. Amplitude of sound waves at a distance 20 meters is 0.012 millimeters. Amplitude of the waves at a distance 30 meters from the sound wave is. So they say at a 20 meters amplitude of the wave is 0.12 millimeters. At what they ask is amplitude of the same wave when it is at a distance 30 meters, as it propagates to a 30 meters. So the amplitude should be less as it propagates away, since the its amplitude keeps decreasing, right? Right. So in the previous question we saw that intensity is proportional to amplitude squared. If you remember, the intensity also is proportional to 1 over r squared. R means the distance. The propagated distance is r. So if r increases, intensity of the wave decreases. If you want, you can write it here as well. Intensity is proportional to 1 over r squared. So what they ask is a combination between, we need is combination between distance and amplitude. I'll choose this. A squared 1 over r squared. Get the root from the both sides. So amplitude is proportional to 1 over r. So I'm going to use this one. You don't have to remember this, but you need to remember these two. Then derive this one when you get a question like this. Right. So for two cases I'll use this one. For the first case, 0.012 millimeters. So that is at a 20 meter. Distance is 20. This is the first one. Then what they ask is for the second one, amplitude. Let's say for the second one, amplitude is A. Proportional to distance they have given is 30 meters. So this is the second one. Then I'll divide second by first one. A divided by 0.012 equals, you have to, when you divide these two, these are reciprocals. If you divide this, this becomes 20 divided by 30. Cancel these two. So A is proportional to 0.012 times 2 divided by 3. If I divide this by 3, 0.004, 0.008. So the units was millimeters. So see that the amplitude, initial amplitude is this much. It has decreased to this much when the wave traveled to a distance 30 meters. So the answer for that should be the fifth one for the 9th question. Right, 10th question. Intensity of a sound is 2 times 10 to the minus 8 watts per square meter. Its intensity level is. So they have given intensity of sound, that is 2 times 10 to the power minus 8. So what they ask is, this is the intensity of the sound. So what they ask is intensity level. So to find intensity level, we need this equation, 10 log I naught I. 10 log 10, I means this value. I naught means 10 to the power minus 12. That is the threshold intensity for the human ear. Minus 12. 10 log 10, 2 times 10 to the power minus 12 plus 12 minus 8. So this is 12 minus 8 means 4. 10 log 10 2. So if it is a multiplication, you know that you can write that multiplication as an addition in logarithms. Then log 10, this is plus log 10, 10 to the power 4. 10 times log 10 2, that is given, the value is given as 0.3. The substitute it 0.3 plus log 10 4 means just 4. So you should know these simplifications is O levels, logarithm simplifications. 10 times 0.3 plus 4. 10 times 4.3. So this is 43 decibels. 43 decibels. So that is the intensity level. This is the intensity of that sound. This is the intensity level of the sound. So the answer for that should be fourth one for the 10th question. 11th question. True sentence about infrasound and ultrasound is. Right. Infrasound and ultrasound. Many students think as it sounds like intra and ultra, these sounds like electromagnetic waves. No, these are not electromagnetic waves. Even though they say infra and ultra, still they are sound waves. Sound wave means these are mechanical waves, right? So any sound wave, whether they are infra or ultra, those sound waves are going to be longitudinal waves, not transverse waves. You know that sound waves are also surely they should be longitudinal waves, not transverse waves. In all the cases, sound waves, if the direction of the wave is this, particles in the medium vibrate parallel to that direction, not normal to that direction. So sound waves are always longitudinal, not transverse. So if I further clarify what infra and ultra means, so 20 hertz to 20,000 hertz, this is the audible frequency range for human ear. So if a sound wave is less than 20 hertz, we call that infrasound. If a sound wave has a higher frequency than 20 hertz, we call those ultra. These are ultra sound waves. But still those two are sound waves, meaning they are longitudinal. So both are longitudinal waves. The answer for the 11th should be second one. Right, 12th question. It is from Doppler's effect. When both observer and sound source move to the same direction at half the velocity of sound, change of frequency heard by the observer is. So let's say velocity of sound is v. So if this is observer and this is source, they say both observer and source move into the same direction with same velocity. Like if you think about the relative motion between these two, they don't have a relative motion. I mean the relative velocity between these two is 0. So this is similar to the observer and source at rest. If there's no relative motion between them, always the observer hears the real frequency. He doesn't hear an apparent frequency. So the apparent frequency is equal to the real frequency. Since they don't have a relative motion between them, they have the same velocity to the same side. So the relative velocity is 0 between those two. So there cannot be a change of frequency. So the answer should be 0, change of frequency. So it is 0%, meaning 0. There cannot be a change. Change is 0. Fifth one for the 12th question. Right, 13th one. In front of a person riding a swing, a sound source emitting sound waves at constant frequency is placed. He hears the minimum frequency. He hears a minimum frequency when. So there's a swing. So he's so this is the observer. He is moving like this. Then there's a sound source in front of him. Let's say this is the source. So what they ask is, what is the position of the observer as he is swinging, that he hears the minimum frequency, minimum apparent frequency. Right. So this f dash, without using equation, you should know the apparent frequency is highest when there is the highest relative velocity between the observer and source, like when they are moving to opposite directions. Opposite means like this. When the relative velocity is highest, and that should reach as well, they should reach each other as well, and the relative velocity should be highest between them. In that case, we will have the highest frequency. If the relative velocity is highest but they are moving away from the source relative to each other, in that case we will hear the minimum frequency. When a source reaches towards the observer, we hear the maximum frequency. If it moves away from the source, we hear the minimum frequency. Minimum frequency. Right. So as the observer swings, here the velocities are 0 at two ends. At this lowest position, if he is moving to this side, he has a Vmax, maximum velocity. When he moves to the other side, he has the maximum velocity to the other side. At this point, the observer is moving towards the source at maximum velocity at this instant, meaning apparent frequency is maximum at this instant. Here the velocity is the highest, apparent frequency should be minimum because the observer is moving away from the source at the highest speed. So at this case, the observer notices the minimum frequency, not here. So the answer should be lowest position, moving away from the source. Lowest position, this is the lowest position, and moving away from the source. 14th question. A sound source emitting sound at frequency 450 Hz moves towards a fixed observer at 33 meters per second. So that's if the sound velocity in still air is 330 meters per second, apparent frequency is. Quickly draw a sketch. So there's the sound source. So the source is emitting. This is the actual frequency of the source, 450 Hz. So then there's the fixed observer. So the speed of the source is 33 meters per second, moving towards the observer. The observer is at rest. If the sound velocity in still air is 300, then from the source, sound waves has this velocity 330 meters per second towards the observer. So what they ask is apparent frequency that is heard by the observer. So this method is easier, like apparent frequency is, just remember, O divided by S. This is a easier method. Apparent frequency is velocity of sound relative to observer divided by velocity of sound relative to source. Source also has S. This is sound, this is source, right? Times F naught, true frequency, actual frequency. So this equation is easier. Just remember this equation whenever you need to find apparent frequency. Right. This is velocity of sound relative to observer. Since the observer is at rest, sound is just reaching 330 meters per second towards the observer. So the relative velocity between the sound wave and the observer should be 330. This is velocity of sound relative to source. Well, sound wave is moving to this side, source also is moving to the same side. So the relative velocity between these two should be the difference, since they are moving to the same side. 330 minus 33 times f naught is given as 450 hertz. Then just divide the whole thing by 33. 10 minus 1, 450. 10 divided by 9 times 450. 5. 50 times 10. So that should be 500 hertz. So the apparent frequency is 500 hertz. So you can see this is higher than 450, since the source is moving towards the observer. It is 500 hertz. So the answer should be third one for the 14th question. Right, 15th question. A sound source moving at constant velocity u and with frequency simple f moves towards a still observer and then passes him. If the sound velocity in air is v, change of apparent frequency is, change of apparent frequency heard by the observer is, that's what they ask. So quickly draw a sketch. There's this sound source which has a constant speed u, and it is moving towards still observer. Observer is at rest, and the velocity of sound is v. So he's moving towards the observer, and then the source passes the observer. And let's say the source is here now, it's still moving at constant velocity u. Now the sound waves are moving to the direction of the observer. Now the sound waves are moving to this direction, towards the observer. So what they ask is a change of apparent frequency. Let's say when the source is here at this side, apparent frequency is f1 dash. Then when the source is at this side, let's say the apparent frequency is f2 dash. f2 dash. So here what we need is the difference between these two apparent frequencies. Okay, first I'll write f1 dash. So what's the equation? O divided by S. Sound velocity relative to observer is divided by sound velocity relative to source. So sound velocity relative to observer divided by sound velocity relative to source times f naught. So what is the sound velocity at this case, right? At this case, sound velocity relative to the observer. Observer is at rest, so the sound velocity is just going to be v. Observer is at rest. Sound velocity related to source. This is a source, this is a sound velocity. Both are moving to the same direction, meaning you have to get the difference in order to find the relative velocity between these two. So it should be v minus u. F naught, that is the true frequency, actual frequency. Then I'll write f2 dash. We'll apply the same equation, VSO divided by VSS, f naught. Now it is this case. This is sound velocity relative to observer. Observer is at rest, so the sound velocity is still just v. This is sound velocity relative to source. Source is moving to this side, wave is moving to this side. So the velocities are opposite directions. So the relative velocity should be this addition of these two velocities. So it is v plus u. V plus u. This is actual frequency, that is f naught. Right. So this is the one frequency, then this is the another frequency, This is the another frequency. In order to get the answer, you need to get the difference of these frequencies. So the difference is this minus this. Vf naught divided by V minus U minus Vf naught divided by V plus U. I'll take Vf naught out. V minus U minus V plus U. Take the common denominator. V minus U, V plus U. Here V plus U minus V minus U. So V plus V minus V cancels off. U minus minus plus 2U. This is V squared minus U squared. So you can arrange this change of apparent frequency 2UVF naught divided by V squared minus U squared. So that is the difference of apparent frequency. So the matching answer to that one should be the second one for the 15th question.